In our last type of problem in this unit, we're looking at how we can show that one side of an equation actually equals the other side. This is a new type of question. My hint here is to start with the more complicated side, and then to use I think about 6 of the hints that I had mentioned previously above in our notes. So if I look at this first example here, um, I'm not even sure what tangent of theta plus cotangent of theta looks like what that graph would look like. But we are trying to show that it's equivalent to this graph, which again, I'm really not sure what that is, but we're trying to show that these two things do, in the end, we can start with one and get to the other. So I look at this, typically addition and subtraction is more complicated than trying to combine things through multiplication or division. So I'm going to start with this side. And if I look at my hints that I have way up here in my notes, one thing says if I I don't see any Pythagorean identities there. I don't see any fractions yet. Can't really factor distributor FOIL, but I could. I can't really do this step 4 yet. I can switch everything to sine or cosine. So that's what I'm going to do in this particular question. Is I'm going to take the tangent and the cotangent and just rewrite them. So let me start out tangent of theta plus cotangent of theta, starting with that side. And I'm just going to rewrite that. Tangent of theta is sine of theta over cosine of theta. And to that, I'm going to add cotangent, which is cosine of theta over sine of theta. Okay, and then I look at my hints again. And if I have fractions, one of my hints was to make or to combine fractions. So to do that, I need common denominators. So in this case, my common denominator would be cosine times sine. So I have my first fraction of sine of theta times cosine of theta. To that, if I put a sine of theta down below, I would need to put a sine of theta up above as well. Okay, and then my next fraction originally was cosine of theta over sine of theta. And to that fraction, I would have to put a cosine of theta down below, which means put a cosine of theta up above as well. Okay, so that's kind of the idea of what I'm putting together. Now I just need to work on simplifying, and I also need to realize that these two denominators here, cosine times sine or sine times cosine, are exactly the same. Okay, so I go to my next line here, go back to blue. In my first fraction here, sine times sine, that's just going to be sine squared in the numerator, so sine of theta being squared. My second numerator is going to be cosine squared. And then I'm kind of combining the fractions at the same time. In the end, I just have cosine of theta times sine of theta. Okay, so I go back up to my list of hints that are in my notes way up above. Hopefully by now you're recognizing that Pythagorean identity. Sine squared plus cosine squared is just 1. And that's going to be over cosine of theta times sine of theta. If you would like to, you may rewrite that as 1 over cosine, so that should be equal symbol there, 1 over cosine of theta times 1 over sine of theta. And 1 over cosine is the same thing as secant. 1 over sine of theta is the same thing as cosecant. And let's go back and see. If we look at the original question, it's always good to keep an eye on the original statement we're trying to get through. Right up here, that's exactly what we were trying to make it equal. And that's it. We're done. We've shown we can start with one side right over here and get through a series of steps, and I want to emphasize clearly shown steps where it's easy to see from your algebra what you did and how you changed things, that you can easily get to that second side. That's hopefully what you're seeing in my work here. Again, there's probably more than one way to solve this. It's just what I've tried to do. But if you have another way of showing your work, that's perfectly fine. Okay, let's look at one more example here. My second example, let's create some more space a second. Okay, so here, if we had to pick a complicated side, I'd say they're basically the same. I don't see an easier version. So I'm just going to start with the left side. So that was cosine over 1 minus sine. Okay, if I look through my list of hints way, way, way up above, a lot of them I do not see right now. Okay, you go through all of them basically. I believe 1 through 4 don't fit, and also the sixth one doesn't fit. I want to check my notes here. I'm sorry, 1 through 3 don't fit, and 5 and 6 don't fit. The only one we haven't tried to work with yet in our notes is step 4, which it says multiply by something equal to 1 that makes a Pythagorean identity in the numerator or the denominator. So what does that mean? That's a bunch of gobbledygook. This is what I mean by it. We're going to take this same fraction and again, in our working with this, hopefully you've realized that you've seen this 1 minus sine of x before. Most of the time you've seen it as 1 minus sine squared of x because that is kind of related to a Pythagorean identity. So you'll as you practice this, you will see this coming up more and more often. But if I think of this as a chunk, if I were to multiply this particular fraction by 1 plus sine of x, something good is going to happen in this denominator. So notice what I did here. It's the same basic idea. It's just the sign in the middle has switched. And if I multiply by it on the bottom to keep things equivalent, I need to multiply by that on the top as well. Okay, so that's what I mean by that fourth step in our notes. Whenever you get really stuck, but you notice that this is kind of related to a Pythagorean identity, try to multiply by it. The idea like this, top and bottom, just switch the sign in the middle, and you'll find out that something kind of nice happens. Okay, so here's what's going to happen. Slide over here just a little bit, make sure I have enough room. If I were to FOIL this together, okay, the first part, 1 times 1 is just 1. Okay, the outside part, 1 times sine is sine. The inside part, negative sine times 1 is negative sine. Those two things cancel out. That's the key to switching the sign right here that's going to make them cancel out. And then the L part of FOIL, a negative sine times another negative sine, gets me negative sine squared. So that's negative sine squared. The top part is basically going to stay the same at this point. Just going to be cosine of x times a 1 plus, I believe it's plus, yep, sine of x. There we go. Okay, so I'm not going to change that too much, the numerator right now. Just kind of keep that the same because I want to focus on this denominator. I want you to look back at your Pythagorean identities, and if you were to rearrange the first identity, you would see that 1 minus sine squared is going to be the same thing as cosine squared. So I'm going to keep the numerator exactly the same. Whoops, gotta erase that. Let's see if I can do that. Shoot. Didn't mean to erase all that. Hopefully you caught what was up there, because I'm going to just kind of keep going here. We're going to have a cosine of x. If you do need to go back, just make sure that you kind of pause the video and go back to it, I guess. But I believe we had a cosine of x times a 1 plus sine of x. in the numerator. And what we were getting ready to do was to replace the whole denominator with cosine squared. That was the substitution we were making. I just got a little bit ahead of myself. Okay, well the cosine squared that's in that denominator, just remember that's really saying cosine times cosine. So if I have a cosine up here, it's going to cancel out with one of the cosines that are down there. Okay, so it's almost like if you want to, you could kind of think about it this way. This is going to cancel out with, and it's going to kind of get rid of that square term, just keep one cosine in the very bottom. And so in the end, we are left with 1 plus sine of x, all divided by cosine of x, which is what we were trying to make it equal at the very beginning. So I apologize for having everything go away so suddenly. Again, make sure you pause and rewind if you need to see some of that work again. But hopefully the entire idea is there overall. Thanks for watching. See ya in class.